Hey guys! Alright, today we're going to do Chapter 8, Section 3, Arithmetic Series. So we've talked about sequences, and remember that in sequences we have our domain is 1, 2, 3, 4, 5, 6, 7, 8, whatever. Okay, they're just integers that are positive starting at 1. For our series, this is a little bit different because we have a sequence, but essentially in a series the only difference is that you're adding all of your terms together. Okay, so I had a sequence of 1, 3, 5, 7, 9. If I was doing that in a series, it would be 1 plus 3 plus 5 plus 7 plus 9, dot, 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 dot. Okay, so a series is an indicated sum of terms of a sequence. If the number of terms added together is infinite, the resulting series is called an infinite series. If a finite number of terms is added, the resulting series is called a finite series. So we're going to be talking about finite series, and then later on we're going to move into infinite series and use limits in order to determine the solutions. So the sum, S sub n, is equal to your first term plus your second term plus your third term, dot, 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 all the way up to a sub n. Okay, of an arithmetic series with first term a sub 1 and a constant difference given by d. Okay, so these are the two formulas that you can use, and you'll notice that they are available on your formula sheet, so you will have them on a test. You just need to look and make sure that you understand that S sub n stands for the sum of an arithmetic series. So S stands for sum, A, that stands for the fact that you're talking about an arithmetic sequence, or series. Okay, so let's do some problems using these formulas just so we can get an idea of how to use them. Number 1 says a student borrowed $4,000 for college. The loan was repaid over a 100-month period with monthly payments as follows. How much did the student pay over the life of the loan? Okay, so first of all, I know that this is arithmetic because what's happening each time is I'm just subtracting 20 cents off of the loan. So that means that my D value is going to be negative 0.2. Okay, then I also know what my first term is. My A sub 1, that's just going to be 60 because that's what I started out with. I also just so happen to know my last term. So I know that my last term, A sub n, is going to be $40.20. Okay, so, excuse me. So if I want to calculate the life of the loan, I know that it was paid over a 100-month period, okay? So I know that my sequence or my series has a total of 100 terms. Okay, so I personally think it would be easier for us to use this one because I know my first term and I know my last term. So I'm going to say the sum of my first 100 terms is going to equal 100 over 2 times my first term, which was 60, plus my last term, which was $40.20. Okay, now on my calculator, I can just enter that in. So I'll take 60 plus $40.20. I'm going to multiply that by 50, and I get a total of $5,010. Okay. So the loan was $5,010. That's how much the student had to pay over the life of the loan. All right, my next one, please remember from the beginning of the year when we talked about summation notation. If you don't remember summation notation, I would suggest going back and relearning it real quick. Pause this video, go back, figure out what summation notation is, and then you can do some of these problems. But remember that in summation notation, this stands for the sum from n equals 1 to 6. So this one, I'm just trying to find the sum of the first 6 terms. Okay? So there's a couple ways you can do this. Either you could write them all out, which it works, but once you approach problems like number 3, you're not going to want to do that because you have 200 terms. So I would not suggest doing that. I would say instead we want to talk about what the first term is, we want to talk about our constant difference, and then we can plug those values into our S sub n formulas. So for this first one here, if I will think about my first term, the first term is when I plug in a 1 for n. So if I plug in a 1 here, my first term, I have 2 times 1, which is 2, plus 7, that would give me 9. Okay? Then I want to think about, what am I doing every time to get to my next term? Maybe it would help me if I figured out what a sub 2 is. Well, if I plug a 2 in here, now I've got 4 plus 7, and that gives me 11. So I can see that my first term is 9, and I can see that my constant difference is 2. I'm adding 2, oops, not 2, yes, 2. I'm adding 2 every time to get to my next term. So, if I go up to my formulas here, I can use this formula because I don't know my last term. You could find it, but I'm just going to use this formula because I haven't used it yet. And I can sum that up. I know I'm using the first 6 terms, so I can say the sum of the first 6 terms is equal to 6 over 2 times 2 times a sub 1, which is 9, plus my constant difference, 2, times n minus 1. In this case, my n value is 6. Okay, so now I can solve that. This is going to be 3, this is 18, 6 minus 1 is 5, times 2 is 10. So I've got 28 times 3. If I plug that into my calculator, I get 84. So the sum of the first 6 terms of this sequence is 84. Now I can do the same thing here. For this formula, I'm just going to use the first term and the last term just because I used the other formula last time. I don't want to make sure you guys know how to use them both. So if I want to find my first term, remember that's when I plug in a 1 here. So I've got 16 minus 3 times 1, that's 16 minus 3, which is 13. Okay, if I want to find my last term in this case is 200. So I'm trying to find my 200th term. Well, if I plug in a 200, I have 16 minus 3 times 200, which gives me negative 584. So I can use this formula up here. My S sub n equals n over 2 times a sub 1 plus a sub n. When I do that, I know I'm adding up my first 200 terms. So I've got 200 over 2 times 13 minus 584. Okay, if I plug that into my calculator, 13 minus 584 gives me negative 571. If I take that times 100, I get negative 57,100. So that's going to be the sum of my first 200 terms of this series. Okay, my last problem. A packer had to fill 100 boxes identically with machine tools. The shipper filled the first box in 13 minutes, but got faster by the same amount each time. Hint, hint, it's arithmetic. Okay? If he filled the last box in 8 minutes, what was the total time it took to fill 100 boxes? So in this case, I know that my first term is 13. I know it took me 13 minutes to fill that first box. I know that my last term, which by the way it says there's 100 boxes, so my 100th term is 8 minutes. It took me 8 minutes to fill that last box. I know that I'm increasing by the same amount each time, so I don't know my D value, but I can use my S sub n equals n over 2 times a sub 1 plus a sub n. So in this case, I'm filling 100 boxes, so the sum of my first 100 terms is going to be 100 over 2 times 13 plus 8. Okay, again, I'm going to plug that into my calculator. So I take 13 plus 8, then I multiply it by 50, and I get 1,050. So it took him 1,050 minutes in order to fill those 100 boxes. And that is everything for section 3.